I hope you remember what we studied in the previous lectures about polynomials. And let's start doing some questions. But before doing that, let's just recap. So we studied about zeros of a polynomial, division algorithm, algebraic identities, factorizations, and relationship between coefficients and zeros. I hope you remember now what all topics we studied. So let's move further in our journey to decode the topic polynomials. We will today solve the numericals to wrap the chapter on a strong note. Question 1. Find the value of p from polynomial x square plus 3x plus p. If one of the zeros of polynomial is 2, so one of the zeros of polynomial is given and that is 2. As 2 is the zero of a polynomial, we know that if alpha is a zero of a polynomial px, then p of alpha is also equal to 0. And substituting x equals to 2, we know that x square plus 3x plus p is actually nothing but 20, actually 2 to the power 2 plus 3 times 2 plus p is nothing but 0. So if I actually solve this, it will be 4 plus 6 plus p equal to 0 and p is nothing but minus 10. How simple it is, right? So what we did actually was, we wanted to find the value of p. And one of the root, or I can say 0 of a polynomial was given and that was 2. So I substitute 2 in the polynomial while knowing the fact that if I'm going to substitute a root of a polynomial in polynomial itself, then the value of polynomial becomes 0. And that is exactly what I did. I substituted, equated it to 0 and found the value of p, which is minus 10. I hope you understood this. So let's move to next question. Next question asks, does the polynomial a to the power 4 plus 4a square plus 5 have real zeros? Now, in the aforementioned polynomial, can I say that a square is x? Like, I'm assuming that a square is x. So, can I change this polynomial to x square plus 4x plus 5? Absolutely. Now, comparing this with ax square plus bx plus c, I can say that b square minus 4ac is what? So, b square is going to be 4 square minus 4 times 1 times 5, and this is actually going to be minus 4. Here d is nothing but d is b square minus 4ac, and b square minus 4ac is nothing but minus 4, and minus 4 is what? Less than 0. Now the discriminant is less than 0, which means what? Which means that the given polynomial does not have any real roots or zeros. So let's move to next question. Before actually moving to next question, I just want to say that if you want to pause the video and try the questions before I solve them, you can absolutely do it. Another question, let's take it. So the question says compute the zeros of polynomial 4x square minus 4x minus 8. Also establish a relationship between the zeros and the coefficients. So let's do it. Now let the given polynomial px equals to like 4x square minus 4x minus 8, which is already given. And I know that to find the zeros, I have to equate it to 0. Now I have to factorize it. So it can be what? It can be, if I take 4 common, it will be x square minus x minus 2 equal to 0. Now it's basically x square minus x minus 2 equal to 0 because 4 cannot be 0. So obviously this has to be 0. Exactly what I'm saying is that a times b, if a times b is 0, and if a is not equal to 0, then obviously b has to be equal to 0. This is exactly what we can understand from this equation. 4 times something is 0, but 4 is not equal to 0. So that something that is multiplied by 4 has to be 0 in that case. Now I'll just do that, splitting the middle term. And after doing that, I'll find x minus 2 times x plus 1, which is equal to 0. And x can be what? 2 comma minus 1. So these are the roots of the equation 4x square minus 4x minus 8. So these are the roots. Now I have to find the relationship between the sum of zeros and the coefficient. So what are the sum of zeros? Sum of zeros, come on fast, it's going to be 1. Whereas this one is equal to what? negative of coefficient of x upon coefficient of x square, as we have studied. So it's going to be negative of 4 by 4, that is nothing but obviously 1. And similarly, if I want to find the relation between what? The relation between the product. So what I'm going to do is, I have to equate the, multiplication of the products with what? It's going to be what exactly? So it's going to be the constant upon the coefficient of x squared. This you already know, right? I will just erase everything and write it down for you to actually understand it more properly. So what is going to be the relation between the product of zeros and coefficients? It's going to be actually minus 1 times 2, which is nothing but minus 2. And this minus 2 can be actually written as minus 8 by 4. And minus 8 by 4 is nothing. It's actually the constant upon the coefficient of x square of this particular equation which we are talking about. So this is equated to this. Hence, left hand side is equals to the right hand side. And we have proved the relationship between zeros and coefficients by both the equation, that is sum of the zeros and product of the zeros as well. So let's move forward. Question 4 states, find the quadratic polynomial if its zeros are what? 0 and under root of 5. So it's pretty simple. I need to find the quadratic polynomial, but we know that a quadratic polynomial can be written using the sum and products of the zeros. Now I know that x square minus alpha plus beta, that is sum of the zeros times x, plus alpha beta, that is product of the zeros, is actually what the polynomial is. So what is the sum of zeros? Sum of zeros is going to be root 5, because root 5 plus 0 is actually root 5. And what is going to be the product of zeros? Product of zeros is going to be 0, because 0 times any number is going to be 0. So 0 times root 5 is going to be 0. So sum is going to be under root of 5, whereas product is going to be what? 0. So if I'm going to substitute this in this, then x square minus sum of zeros is under root 5 times x, and product of zeros is zeros. So this polynomial will be what? X square minus under root of 5 times x. So this is basically what is going to be the polynomial. Let's move further. Now the question states, find the value of x in the polynomial 2a square plus 2xa plus 5a plus 10 if a plus x is one of its factors. Now obviously this is the polynomial that is given, right? And a plus x is a factor of this, correct? So since a plus x is actually the factor of this, so f of negative of x is going to be 0, correct? Because what they are saying is that a plus x is a factor. So if it's a factor, then if this is equated to 0, then x is equals to minus a. That means minus a when substituted in this, or I could say actually, because a is what the variable is, I could say that minus x equals to a. And if I substitute minus x into this, then what is going to be? The polynomial is going to be 0. Now understand it in this way. I am saying a plus x is a factor. Suppose a plus x, this is your x, a plus x times a plus y is actually how the factorization of this occurs, right? And this is equal to 0. So suppose this was the factor that is given and this is the factor that I assumed. So this factor when equated to 0 will give me value what? It will give that a is equals to negative of x, which I have written here. So a equals to negative of x. And I know this is a root. And when a root substituted in the polynomial, then it will do what? It will make that polynomial equal to 0. So I'm going to exactly do that. I'll substitute minus x into this and equate it to 0. So what it's going to be? It's going to be 2x square minus 2x square minus 5x plus 10 equal to 0. How did I get this equation? I just substituted minus x in place of a in this equation that I'm marking. So this is the equation in which I'm substituting it. So now what I'm going to do is 2x square minus 5x plus 10 equal to 0. So that means that minus 5x plus 10 is equal to 0. And x is going to be nothing but 10 by 5. Therefore, x is going to be what? 2. So this is actually the answer, that x is nothing but x is 2. I hope you understood this. So we have reached the end of our discussion. Hope you found that helpful. Now you can actually visit to EduRev to attend the respective tests so as to check your understanding on the topic. Stay tuned for more amazing videos and thank you.